our next lesson is on compound inequalities. So compound inequalities in general are when you have two different inequalities as one singular problem. So it's like talking about a variable, but it has two different constraints. And we'll start making this this foldable, but this is kind of the end product of what it's going to look like. You're going to start with just a blank sheet of paper, turned kind of like the long way here. Okay, and you're going to fold it in half, just like so. Remember, as close you can match up the corners, the more accurate your fold's going to be, right? The nicer it's going to look. So now this opens as kind of just like one window, but we want to separate it into two different types of compound inequalities. So we're now going to fold it down to make that middle crease. Okay, and we're going to open it up and just cut along that crease you just made to make the windows. Okay. Alright, so let's talk about the two types of compound inequalities. There are compound inequalities containing and compound inequalities containing or. Let's talk about what that means, what the difference is. For compound inequalities containing and, that's when x is restricted two different ways. So for this one here, x has to be in between 3 and 7. So if we kind of cover one of them up, this reads as x has to be greater than or equal to 3. And x also has to be less than 7. So you can break it up to literally write in the word and, or you can just put it like this. So x is greater than or equal to 3 and x is less than 7. So it's like reading it backwards, reading it forwards. Now if you want to show this as a graph, well, what are the values where x is greater than or equal to 3 and less than 7? So we start looking at the number line. We know that it's greater than or equal to 3, so that looks like a closed circle, right? And then shading all the way to the right. But I know that x also has to be less than 7. So that would be an open circle and all those numbers to the left. So when I kind of put that together, you can see that x has to be between 3 and 7, but it can be 3. And as we start solving compound inequalities, you'll see how the graph is made. So those are and inequalities. Now let's talk about the or inequalities. This is when there are two different opportunities for x to be a number. So if you're given a problem like x is greater than 2 or x is less than -1, to graph that, you would just graph each of those separately. So x is greater than 2 are all the values, not including 2, that are greater than 2. And then separately, x is less than -1 are all the values less than, but not equal to, -1. So that's how you'd show that solution. So they're very different. Usually and is going to be a smaller range of solutions, right? Between 3 and 7. Whereas an or gives you more opportunities, right? It can be all these numbers or all these numbers. And we're going to do some examples on the inside. Alright, so we're going to open this top part and we're going to talk about compound inequalities containing and. So here's my first example. -2 is less than or equal to x minus 3, which is less than 4. So how would we solve that problem? Well, just thinking back to solving inequalities and solving equations, we want to try to get the variable by itself. So my first step in solving this problem is going to be to add 3, because I know that's going to get rid of that 3. But take a look at this. I have 2 inequality symbols. So if I add 3 here, and I want to keep everything balanced, I've got to add 3 on this side, and add 3 on that side. So my first step, okay, whenever I do an operation, I have to do it to every side of the inequalities. So we're going to add 3 to all sides. Now let's see what happens when I do that. Negative 2 plus 3 is positive 1, less than or equal to. Those cancel, so I'm left with just x now. And that's less than 4 plus 3 is 7. Now if there was more, if this was say like 4x, then I'd divide by 4 on every single side. It's not though, it's just x. So I know that x has to be in between 1 and 7, right? Because it's greater than or equal to 1, but it's less than 7. So how do I show that on the number line? Well, I know that it's between 1 and 7, so I'm going to put circles on 1 and 7. I know that it could be 1, so this should be a closed circle. Can't be 7, so that should stay open. And x are the values between those numbers. So we're just going to go ahead and say that's the values between those numbers. So it's kind of nice, even though it looks confusing, when it's written as kind of all grouped and bunched together. But really, it shows you exactly how to graph it, because it's the values between 1 and 7. So you just go to 1 and 7, and it's between there, right? X is between there. So it tells you exactly where to graph it, which is really nice. And so now we're going to flip this one back up and do example 2. So example 2, we've got 2y minus 3 is greater than or equal to negative 15, and y minus 3 is less than or equal to negative 4. So and inequalities don't always have to be written grouped together, right? Sometimes they're just going to be the word and. And in this case, we're going to have to solve each of these separately. So let's see what that looks like. On the left side, I'm going to add 3 to both sides. And I'm left with 2y is greater than or equal to negative 12. I keep going, divide by 2. And I'm left with y is greater than or equal to negative 6. On the right side, I'm just adding 3 to both sides. And I'm left with y is less than or equal to negative 1. So let's see, what does that mean? So let's graph them separately and see what happens. For this one here, y is greater than or equal to negative 6. So here's negative 6. If I were to graph that, it's all these values that are greater than or equal to them, to negative 6. If I were to graph this one, it's all the values that are less than or equal to negative 1. But this is an and inequality. So it's not the values together, it's what they have in common. So that's why it's called the intersection. Okay? So here, my real solution is going to be the values from -6 to -1. Okay? Because that's where it's true for both. Right? It's greater than -6, but less than -1. So it's these values right here. So this would be my answer, the intersection. So we finished talking about the inequalities containing and, how they can be grouped together or separately, right? And it's always the intersection. Okay, so it's got to be true for both this and that. Now we're going to close this part, and we're going to move down to inequalities containing or. So or inequalities are always written separately. They're never combined together because there's less of a restriction on them. So they're considered separate. So let's kind of open these up and we'll go over our examples. For example 1, I know that 2x plus 12 is greater than or equal to 30. Or 2 plus 4x is less than 10. So again, we're going to solve each of these individually. So we'll start over on the left. Subtract 12 from both sides. That crosses out, and I have 2x is greater than or equal to 18. And I divide both sides by 2. And x is greater than or equal to 9. And on the right side now, I have to move this 2 over, so I'm subtracting 2 from both sides. And those cancel. So I have 4x is less than 8. And now I divide both sides by 4. And x is less than 8 divided by 4 is 2. So I'm going to graph each of those. So I've got to show both 2 and 9 on my number line. So if we start at, say, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So there's my number line. Now x can either be values greater than or equal to 9, so that's those values, or less than 2, which is these values. So when you have an or inequality, there's no intersection here, okay? It's either going to be these values or these values. Okay, so it can't be 4 because 4 is not less than 2, and it's not greater than or equal to 9. So it can't be these values here. Let's move on to example 2. Similar strategy. I have an or, but I've got 2 separate inequalities I have to solve. So let's start with the left one. I subtract 7 from both sides. Negative 2m is less than or equal to 6. Divide by negative 2. M is greater than or equal to negative 3. Or, let's go over here. Subtract 12 from both sides. I'm left with 5m is greater than 25. Divide both sides by 5. And I've got m is greater than 5. So let's take a look at these two right here. So m can be greater than or equal to -3, or it can be greater than 5. Look what happens when I graph those. Greater than or equal to -3 is all of these values here. M is greater than 5, so that's, well, wait a minute. If m can be greater than or equal to -3, of course it can be greater than 5. So I don't really have to draw in that line again, okay, because it kind of copies itself. I'm not going to make it all these values and say, oh, it could also be these ones, right? Because I only need one line to represent all of those values. So in some cases, when you have an or, it's not going to look like it's going two separate ways. Sometimes they can overlap, okay? Because this is actually included in this. On the left side, you're going to do these two on your own problems. So -1 is less than 9 plus x, which is less than 17. And x plus 8 is greater than 9, and x over 7 is less than or equal to 1. Okay, so solve and graph those, show your teacher, and then you can move on to the practice problems from the textbook.